Have you ever wondered why you see lightning before you hear the thunder? It's a question that's puzzled many, and the answer lies in the enigma of sound. You see, sound is a type of energy that's made by vibrations. Imagine this: you're plucking a guitar string. The string vibrates back and forth, and these vibrations cause the air particles around the string to move, creating waves of pressure that ripple outwards. These pressure waves are what we perceive as sound. But here's the catch. These pressure waves, or sound, don't move instantaneously. They travel at a certain speed. In air, sound zips along at approximately 343 meters per second. It might sound fast, but let's put it into perspective. If you were to race a sound wave in a supersonic jet, you'd win hands down. If you were light, you'd leave the sound wave in the dust. Light, on the other hand, is a speed demon. It travels at a mind-boggling speed of 299,792 kilometers per second. That's why when you flip a light switch, the room lights up instantly. And it's also why you see the flash of lightning long before you hear the rumble of thunder. To visualize this, imagine you're at a baseball game. You see the player swing and hit the ball, but there's a tiny delay before you hear the crack of the bat. That's because the light from the event reached your eyes almost instantly, but the sound took a little longer to travel to your ears. So, in essence, sound and light are like two friends in a constant race, with light always reaching the finish line first. This discrepancy in speed is why we see things before we hear them. So, the next time you see lightning and count the seconds before you hear the thunder, you're actually measuring the speed of sound. It's science in action, happening right before your eyes and ears. So keep counting and keep exploring the fascinating world of sound. But did you know that the speed of sound isn't always the same? It's a fascinating concept, and today we're diving into the factors that can influence this speed. Let's start with temperature. Imagine a lazy summer day where the air is warm and thick. In this setting, sound travels faster than it would on a chilly winter morning. Why is that? Well, in warm air, particles move faster. This rapid movement allows sound waves to be transmitted more quickly. On the flip side, in colder air, particles move slower, slowing down the speed of sound. Next on our list of factors is humidity, the amount of water vapor in the air. It might seem counterintuitive, but sound actually travels faster in damp air than in dry air. This is because water vapor molecules are lighter than air molecules, which makes it easier for sound to travel. And finally, let's discuss the medium through which sound is traveling. You might remember from science class that matter exists in three states: solids, liquids, and gases. Now, picture a pebble falling into a pond and creating ripples, or imagine tapping a metal rod and feeling the vibrations. These are examples of sound traveling through different mediums. Sound travels fastest through solids, like our metal rod, because the particles in solids are closely packed together. It travels slower in liquids, like our pond, because the particles have more room to move around. And it travels slowest in gases, like the air we breathe, because the particles are spread out the most. So in essence, the speed of sound is a bit of a chameleon, changing based on the conditions it encounters. It's not just a matter of how fast something can make a noise, it's about the temperature, the humidity, and the medium the sound has to travel through. So, the speed of sound isn't a constant. It's influenced by what it's traveling through and the conditions of the environment. Quite the sonic journey, wouldn't you say? To sum up, sound is a fascinating phenomenon that is more complex than it might seem at first. This captivating enigma we've come to know as sound is birthed from the simple act of vibration. These vibrations, like a stone cast into a pond, ripple outwards, creating waves that travel at about 343 meters per second through the air. But remember, sound isn't one size fits all. Its speed can be a capricious character, dancing to the tune of different variables. The medium it pirouettes through, and the temperature and humidity of its grand stage all play their parts in this performance. Whether it's cutting through the frosty morning air or diving deep into the ocean's depths, sound adapts, adjusts, and keeps on moving. So the world of sound is a symphony of physics, full of rhythms, waves, and speeds waiting to be explored. The next time you listen to your favorite song, remember, you're experiencing the marvel of sound waves traveling through the air.